Hi guys, welcome to a very quick video on probability and sampling. We're going to go ahead and figure out how to solve for probability. What do we use probability for? And then what are some of the unique importances of probability and using a probable sample? So what is probability? It's the likelihood that a particular outcome out of all the possible outcomes will actually occur. Probability is really important to inferential statistics because we make conclusions about a population based on the data that we get from a sample. And using probability, we can make assumptions of what the data will look like in a future data collection or in the coming weeks, in the coming months, and etc. So probability is equal to, when we're looking at a mathematical equation, probability is going to be equal to the number of successes over the number of trials. And you should be able to convert this into a percentage to be able to get a percent of probability. So take this example in regards to weather across the last 14 days. So we have 14 different data points here, and each row of data represents how the weather overall was across each day. So we have rain, windy, sunshine, and this is different across each day for the last 14 days. Let's find the probability of rain within the 14 days and see if it can help us make an assumption of what it might look like in the next couple of days. So first we're going to find the number of successes. So this would be equal to how many times rain actually showed up across the 14 days. So we have 1, 2, 3, 4, 5, 6, 7, 8 days of rain. So it's going to be 8 on the top here. Then the bottom is going to be the total number of trials. We have 14 days here, so I'm just going to put 14. So now you're going to do a simple math division where you're going to go ahead and divide 8 by 14. This, if you do just a normal division problem, you should be able to get roughly 0.57. And if we convert this into a percentage, we're going to get about 57%. Using this probability equation, we have just made an assumption and we have made an inferential statistic conclusion saying that 57% of the time across these 14 days, the weather was rain. You can continue to use this probability equation with larger data sets and be able to also conclude what the weather might look like in the upcoming days. Or in the month of February, here was the weather, how many times did it rain? Maybe you can make an assumption saying, okay, because we have this data set, next year in February, there might be a 40% chance that most of the time it'll be rain. Or there might be a 40% chance that most of the time it'll be snow, right? So probability really helps us kind of get a good inferential statistic rolling so that we can make assumptions about our population based on our data sample. What is probability sampling and why is it important? Well, the samples are randomly selected, so this is important, rather than conveniently selected, right? Everyone in the population has an equal chance, so it takes out that bias sampling error that we often run into. You want to keep an eye out for sampling bias, and you want to have a diverse, unbiased sample. So probability essentially helps us to kind of get all of this checked out for our data set, and it really helps us from not making any sampling biases within our data set, which may make our data messy and dirty. Okay, so that is just a quick little demo on finding probability using this little equation.